Hi all, this is Sujitra and welcome to this AI series. Today we are diving into tokenization, which is the critical first step in any natural language processing pipeline. Before any AI model can process text, we need to break it down into manageable pieces called tokens. The way we do this significantly affects our model's performance. Today we'll be looking at three main approaches of tokenization. The first is word-based tokenization, the second is character-based tokenization, and the third is subword tokenization. First, let's look into word-based tokenization. Look at this example. We are feeding in I love machine learning as the input. Each word is separated into a token, and in the output, we get each word represented as a token. The main challenge with word-based tokenization is vocabulary explosion. For example, consider these words: play, place, played, playing. In word-based tokenization, each of this is treated as a separate token, requiring 4 different entries in our vocabulary. This problem becomes severe with morphologically rich languages or technical texts with many variations of similar words. A typical word-based vocabulary might require hundreds of thousands of tokens to achieve good coverage. Okay, now let's examine character-based tokenization. Look at this example. We are feeding in hello as our input. In the output, we get each letter categorized into an individual token. Character tokenization solves the vocabulary explosion problem with a tiny vocabulary, just the alphabet and the special characters. It can handle any word, even the misspellings. However, it creates very long sequences since each character is a token, and single characters often lack meaningful semantic information. For example, the letter A alone doesn't tell us if it's an article or part of another word. This brings us to subword tokenization. Subword tokenization uses byte pair encoding, which offers a middle ground. So here's how it works. It starts with a vocabulary of individual characters and counts the frequency of character pairs in your text. It merges the most frequent pair to create a new token, and it repeats this until you reach your desired vocabulary size. For example, in the word understanding, first iteration might merge un, which is the frequent prefix. Next, it might merge ing, which is the frequent suffix. In the result, we get understanding. Okay, now that we understand these different tokenization methods, let's explore when to use each one of this. This choice here will significantly improve your model's performance. Let's start with word-based tokenization. This approach shines in specific scenarios. Imagine you're building a sentiment analysis system for customer reviews of a specific product. You're dealing with a limited formal vocabulary where customers use standard English to express their opinions. In this case, word-based tokenization is perfect. Your vocabulary is contained, your text is clean, and you need fast processing. The shorter sequences mean quicker processing times. And since you're working with standard product terminology, vocabulary explosion is not a major concern. Okay, now let's shift to character-based tokenization. This becomes your best friend when you're dealing with messy real-world data. Think about social media posts or informal messages. Users might misspell words, use creative spellings, or mix emojis and special characters. Character-based tokenization handles all of this beautifully. It's also particularly valuable when using languages like Chinese, where word boundaries are not clearly marked. Every character counts, and this approach makes sure that no character is missed. Now, let's explore subword tokenization, which has become the go-to choice for modern language models. Here's why. Imagine you're building a system to process scientific papers. You'll encounter terms like neuroplasticity or immunofluorescence. Instead of treating these as unknown words or breaking them into individual characters, subword tokenization intelligently breaks down these words into meaningful pieces. Neuro plus plasticity or immuno plus fluorescence. This is incredibly powerful for technical vocabulary, and it also works beautifully across multiple languages. When you're making this choice about tokenization for your own project, think about the data and the requirements. Are you working with clean, formal text with a limited vocabulary? Then word-based tokenization might be your answer. Dealing with user-generated content or multiple languages? Lean towards subword tokenization. Need to handle any possible text input, including misspellings? Then character-based tokenization could be your solution. Okay, now let's recap our key points about tokenization. It's the foundation of text processing. Word-based tokenization struggles with vocabulary size. Character-based tokenization handles any text but loses meaning. Subword tokenization balances these trade-offs. Modern models predominantly use subword approaches. Next week, we'll explore how these tokens get converted into embeddings, building on what we have learned today. See you in the next video.